Welcome. Today, we're diving into the essential requirements for lighting and noise levels in pharmaceutical manufacturing. I'm Dr. S.K. Singh, and together we'll explore how these factors impact safety, quality, and efficiency in this critical industry. Let's get started. Let's start by looking at the key environmental parameters that really shape our workspace. Lighting isn't just about brightness, it's about how evenly that light spreads and how it affects what we see. Noise levels matter too, because they impact focus and safety. Together, lighting and noise influence product quality, operator safety, and how well inspections are done. Our main goals here are clear. We want to ensure visual accuracy, prevent operator fatigue, keep conditions safe, and support smooth cleanroom operations. When it comes to regulatory expectations, there are several key factors we need to keep in mind. First, adequate lighting is essential for smooth operations. Noise exposure must be controlled to protect everyone on site. Personnel safety measures are non-negotiable, alongside regular monitoring and maintenance to ensure ongoing compliance. These requirements aren't just about rules. They're about making sure environmental conditions don't negatively impact product quality, process efficiency, or how well people perform their tasks. Around the world, standards like WHO GMP, EU GMP, OSHA, and ISO set clear guidelines on lighting, ventilation, noise, and cleanroom design. Let's talk about common lighting units you'll encounter: lux and foot candle. 1 foot candle is roughly equal to 10.76 lux. Why does this matter? Because proper lighting is crucial in pharma environments. It helps us inspect products accurately, avoid operator mistakes, and keep equipment use safe. Good lighting also ensures documents meet GMP standards and makes cleaning easier. Areas like inspection stations, sampling booths, labs, and packaging lines all need this high level of illumination to keep everything running smoothly. Poor lighting can cause a chain reaction of problems, from inspection failures and documentation mistakes to operator fatigue and even safety incidents. So, when we design lighting, we focus on uniform illumination to avoid shadows, reduce glare that can strain the eyes, and ensure emergency lighting is reliable. Energy efficiency matters too, especially in cleanroom environments where specialized fixtures are required. Typical standards guide us on the right illumination levels. For example, general manufacturing needs 300 to 500 lux, while visual inspection areas demand much brighter light, up to 1500 lux. When designing lighting for pharmaceutical spaces, there are key factors we need to consider. First, the lux level, how bright the area should be. Then, uniformity ratio, which ensures even light distribution without harsh shadows. Color rendering index, or CRI, is crucial. We aim for a CRI above 80 so colors appear true, helping with accurate visual inspection. Color temperature also matters, influencing the overall feel of the space. Common lighting types include LED, fluorescent, and emergency systems. For cleanrooms, fixtures are flush-mounted, sealed, dust-proof, easy to clean, and designed to generate minimal heat. These features help maintain strict hygiene and safety standards. Let's walk through a lighting calculation example to see how it works in practice. We start with some given data: a total luminous flux of 60,000 lumens, a room area of 120 square meters, a utilization factor of 0.7, and a maintenance factor of 0.8. Using the formula, we multiply the lumens by both factors, then divide by the area. The result is 280 lux. This level is fine for a warehouse space, but it wouldn't be enough for an inspection area where more precise lighting is needed. Let's start by understanding noise levels and why they matter. Noise is measured in decibels, or dB, which tells us how loud a sound is. Humans can hear sounds from 0 decibels, which is nearly silent, up to around 140 decibels, which can be painfully loud. In the pharmaceutical industry, controlling noise is crucial because unwanted sound can disrupt operator focus, interfere with communication, and even pose safety risks. Over time, it can also damage hearing. Common noise sources include HVAC systems, compressors, granulation and packaging machines, air handling units, and vacuum pumps. Excessive noise has a real impact. It can cause hearing loss, increase stress and fatigue, and make communication much harder. When noise gets out of control, productivity drops and mistakes happen more often. That's why controlling noise is so important. Our goal is to keep the workplace safe and comfortable for everyone. Different environments have different noise limits. For example, OSHA allows up to 85 decibels over 8 hours, while offices aim for 45 to 55 decibels. In places like pharmaceutical production or clean rooms, the limits are even lower to protect both people and processes. Let's look at an example of how to calculate combined noise levels. We have two machines, one at 70 decibels, the other at 73. To find the total noise, we use a formula that adds their sound energy logarithmically. When we plug in the numbers, the combined noise comes out to about 75 decibels. This level is still within acceptable limits for pharmaceutical production, but it's wise to keep monitoring to ensure safety and compliance. Now, let's walk through how we qualify lighting and noise levels in a project. It starts with design qualification, reviewing the lighting design, assessing noise, and evaluating risks. Then, installation qualification makes sure fixtures are installed correctly, noise control systems work, and instruments are calibrated. Operational qualification follows, with measurements of light levels, noise, and emergency lighting checks. Finally, performance qualification involves ongoing monitoring and tracking environmental trends over time. Each step builds on the last to ensure safety and comfort. When it comes to monitoring, we rely on specific instruments tailored to what we need to measure. For lighting, we use lux meters and illumination meters, tools that help us quantify light levels precisely. For noise, sound level meters, dosimeters, and frequency analyzers give us detailed insights into sound intensity and quality. But having the right tools isn't enough. They must be calibrated regularly, and monitoring should follow a set schedule. We keep thorough, traceable records. Monitoring happens at key moments, during qualification, after any changes, and as part of routine GMP verification. Now, let's look at corrective actions, the practical steps we take when things go off track. This includes replacing fixtures, maintaining equipment, adding acoustic insulation, and balancing HVAC systems. Preventive maintenance plays a big role too. Common problems like low illumination or flickering lights often point to aging fixtures or electrical issues. Noise from equipment or HVAC can cause fatigue or even hearing risks. By identifying causes and impacts, we can troubleshoot effectively and keep operations running smoothly. Let's look at the final outcome of our case study in the packaging area. We improved lighting from 220 lux to a bright 550 lux, well above the recommended 500. Noise levels dropped from 82 decibels to a more manageable 72. These changes boosted inspection efficiency and reduced operator complaints. The root causes were clear: poor lighting and excessive machine vibration. So we added LED fixtures, isolated vibrations, and installed acoustic panels. Small changes, big impact. On this slide, we wrap up with the key references that guide our approach to lighting and noise control, from WHO and OSHA standards to ISO and CDC guidelines. Proper lighting and noise management aren't just nice to have. They're essential for safe, compliant, and efficient pharmaceutical manufacturing. To get it right, we need thoughtful facility design, ongoing monitoring, regular maintenance, and precise calibration. These elements together ensure compliance, protect personnel, improve product inspection, and boost overall efficiency. That brings us to the end of our presentation. For any further support or questions, please don't hesitate to reach out. Thank you for your time and attention. It's been a pleasure sharing this with you today.